Welcome back. This is tutorial 4 on competency 4, conduct a continuity test of cables. Competency number 4, demonstrate how to conduct a continuity check on coaxial cable which is terminated with RF connectors on both ends. What we've got is a radio frequency cable and we've got 2 plugs on each end, and you know it's a plug because in the plug there is a pin. So there's a pin on each end, so each end is a plug, and it's your job to convince the assessor that you know how to do a check, a continuity check. You've just soldered it up and now you've got to test it to make sure it's okay. Well, to do that you'd use an ohm meter, and these days it's pretty hard to get an ohm meter on its own. So you would use a multimeter, and the multimeter would have to be switched to the ohm scale. This is the ohms area of the multimeter here. So the first thing you would do is, I'm not showing the leads in this, the leads would come out of there and there for the multimeter. So I'm going to thicker line for you, make it a bit clearer. And so we need to be switched to ohms, and the first test we need to do is switch to a high ohms range, and the high ohms range is there, I believe. It says 200 kilo ohm range. So you'd switch to the high ohms range and you would put the multimeter, one lead on the pin and the other lead onto the outside. And since there's shouldn't be a circuit here because the other end of the plug should be open circuit, this end is open circuit, and the center conductor should not be touching the outer shield. So you would read a high resistance there, or infinite resistance. So you would read a high resistance with the high ohm scale. So on the high ohm scale, going between the center conductor and the outer conductor and leaving the other end open, you should read a very, very high resistance here, or an open circuit. Alright, so we've checked for a high resistance on one end between the pin and the shield, and we read a high resistance. The next test is to check that there's actually continuity between the shield at this end and the shield at that end, and there's also continuity between the pin at this end and the pin at that end. Now, to do that we use a low ohm scale because we're expecting to find a very low resistance here. Remember, this portion of the multimeter is ohms. And first, when we measured between the center conductor and outer conductor, we did a on the high ohm scale, and we were expecting to find an infinite resistance between the center conductor and the outside because they shouldn't be touching. However, the two shields should be touching. So if we put an ohm meter onto that shield and an ohm meter onto this shield, we should measure a very low resistance because it's just two wires joined together. A very low resistance there. Similarly, if we connect the ohm meter to this pin and the ohm meter to that pin, on the low ohm scale, we should also get a very low resistance. There is another way. Sometimes it's not possible to bring both ends of the coaxial cable to you. So if you wanted to do a continuity check, you could get some wire and short circuit this end, short circuit the braid to the pin just with some strap wire, and then if you put on the low ohm scale, if you put the multimeter between the pin and the outer conductor, you would be measuring the resistance of the copper wire all the way through and then back through the braid to the short circuit. So you would expect to get, again, a very low resistance there. That's all you need to know about testing a RF cable for continuity. What I'd recommend to you, if you don't have one, because you're going to need one, and you will have fun owning one, is buy yourself a cheap multimeter like this. You can get them from most online or from hobbyist outlets in Australia, and or an automotive business will sell a good multimeter, and that'll only cost you about $10 or $12. It won't be a good multimeter, but it will be good to learn on, and $10 worth of training. It doesn't matter if you blow it up. You go and buy another one. Cost of a magazine. And when you get more familiar with the use of multimeters, then you can go out and buy yourself an expensive one. The only thing to watch with the cheap ones is don't go putting them into PowerPoints, because quite often the insulation on the leads of the cheap ones is not designed to withstand high voltages. Anyway, I'm deviating off the schedule here. We're going to stick to discussing the competencies. That's the end of competency number 4.